When a process keeps failing, most people rush to fix what they can see. They swap a part, add a rule, or blame someone for making a mistake. But the real cause often hides deeper, beneath the surface, tangled among habits, systems, and conditions. That's where the fishbone diagram comes in. It's not just a drawing. It's a thinking tool that helps you see how different factors connect to create a problem. And once you see those connections clearly, you can fix issues for good, instead of fighting the same fires over and over. If you're pursuing your Six Sigma certification, the fishbone diagram, also known as the cause and effect diagram or Ishikawa diagram, is one of the most essential tools you'll use in the analyze phase of DMAIC. It's designed to help teams brainstorm and organize possible causes of a problem in a structured way. Imagine the fishbone shape. The problem statement forms the fish's head, and each main category of potential causes branches off like bones along the spine. Under each branch, you explore more detailed contributing factors until you uncover what's really behind the issue. In plain English, it's a way to sort your thoughts when things go wrong. Instead of guessing or relying on gut feeling, the fishbone diagram forces you to ask why, again and again, until you get to a cause you can act on. It's one of the simplest tools in Six Sigma, but also one of the most powerful because it shifts your mindset from blame to understanding. Let's walk through a real-world example. Imagine a small food production company that bakes bottled salad dressings. Over the past few months, customer complaints have spiked because some bottles arrive leaking. The quality manager decides to lead a team through a root cause analysis using a fishbone diagram. They start by writing the problem statement on the right side of a whiteboard, leaking salad dressing bottles. That's the fish's head. Then, they draw a long line to the left and add the main bones, each representing a broad category of causes. In manufacturing, these often include machine, method, material, manpower, measurement, and environment, commonly known as the 6 M's. But you can adjust them for any industry. For example, in a hospital, you might use categories like policy, people, equipment, or procedures. Under machine, the team lists potential issues like incorrect sealing temperature or misaligned equipment. Under material, they consider whether the bottles or caps might be defective. Method includes the filling process or the order in which caps are tightened. Manpower explores operator training or fatigue. Environment might include humidity or temperature during production. Measurement checks whether the inspection process is catching defects early enough. As the discussion unfolds, the whiteboard fills with ideas. It's not about being right at this stage. It's about capturing everything that could possibly contribute. The fishbone diagram acts as a visual memory map, connecting big categories to smaller details so patterns start to emerge. After brainstorming, the team begins testing some of these theories. They examine the sealing machine and discover that during the evening shift, the sealing temperature fluctuates more than it should. Further investigation reveals that one of the heating elements in the sealer wears down faster than expected because of dust buildup from nearby packaging materials. Cleaning schedules hadn't accounted for that. The root cause wasn't the bottles or the workers. It was an overlooked maintenance issue in the environment and machine setup. That's the power of the fishbone diagram. It helps teams move from symptoms, leaking bottles, to root causes, equipment and maintenance issues. Without this structured exploration, they might have kept replacing caps or retraining workers without ever solving the real problem. Now, while the fishbone diagram looks simple, there are some pitfalls that can limit its value if you're not careful. One common mistake is using it like a checklist instead of a thinking tool. Some teams just fill in the categories quickly, guessing causes without real discussion, and then stop there. But the magic of this method comes from conversation, the back-and-forth questioning that challenges assumptions. The diagram is only as good as the dialogue behind it. Another pitfall is focusing too narrowly on one area too early. People tend to gravitate toward causes they're familiar with. For instance, maintenance staff might blame the machine, while quality staff might blame the material. But true root cause analysis requires open-mindedness. Encourage everyone to look across all categories, even the ones outside their comfort zone. The more diverse your perspectives, the more complete your fishbone diagram becomes. A third trap is stopping at the first plausible cause. Just because something looks suspicious doesn't mean it's the root cause. The best practice is to use the fishbone diagram alongside the 5 whys technique. Keep asking why until you reach a cause you can control and verify. The goal isn't to list endless possibilities. It's to find causes that you can test with data. And finally, some teams forget to validate their findings. After identifying likely causes, it's critical to confirm them with real measurements or experiments. The fishbone diagram organizes your hypotheses, but it's data that proves them. In Six Sigma, that's the bridge between analyze and improve. What makes this tool so valuable for those earning a Six Sigma certification is that it captures both the analytical and collaborative sides of problem solving. It helps you think like an investigator, but work like a team. It brings structure to brainstorming and clarity to chaos. Whether you're solving a manufacturing defect, a service delay, or an administrative bottleneck, the fishbone diagram gives you a way to visualize complexity and focus your efforts where they matter most. You'll also find that once people learn to use this tool, they start to see systems differently. Problems stop looking like isolated events and start revealing patterns. A customer complaint isn't just one bad product. It's a clue about how processes, people, and materials interact. That systems thinking is exactly what sets Six Sigma professionals apart from casual problem solvers. Even outside of formal projects, the fishbone mindset helps teams communicate better. Instead of jumping straight to blame or opinions, they learn to explore evidence. They stop asking, "Who did this?" and start asking, "What in the system allowed this to happen?" That simple shift changes everything, from morale to results. Of course, like any tool, the fishbone diagram only works when you use it intentionally. It's not about the prettiest diagram or the fanciest labels. It's about the process of discovery. When done right, it gives you a roadmap for deeper understanding and more lasting solutions. So, what's the takeaway? The fishbone diagram isn't just a way to draw causes on a whiteboard. It's a way to think clearly in a world of complexity. It teaches you that every problem has multiple layers, and the real value lies in uncovering how those layers interact. If you're studying for your Six Sigma certification, make this tool one of your go-tos. Practice it often. Use it at work, in projects, even in everyday problem solving. Because once you learn to think in terms of causes and effects instead of blame and luck, you'll not only fix problems faster, you'll prevent them from returning. And that's the real goal of continuous improvement. Not just solving what's wrong today, but building a system that stays right tomorrow.